We are in section 3.1, which is over rate of change. Now we're going to go to the box that says Essential Understanding on page 167. It says that you can use ratios. By the way, a ratio is a fraction, so you can use fractions to show a relationship between changing quantities. So a fraction has two quantities, the numerator and denominator. You can use a ratio to show the relationship between those two quantities as they change, such as a vertical and horizontal change. So here's your definition. A rate of change shows the relationship between two changing quantities. When one quantity depends on the other, the following is true. So the rate of change represents the change in the dependent variable divided by the change in the independent variable. So I'm going to do a problem, and I just want you to watch it. You don't need to write this down, but if you want to, you can. But let's look at this together. So here is what the problem states. This table shows the distance a band marches over time. Is the rate of change in distance with respect to time constant? So here's what it says again. First question. Is the rate of change in distance respect to time constant? So I want to know, is the change in both of these constant from one to the next? And then I want to know, what does the rate of change represent? So here, remember what your definition is. Your definition of rate of change represents a fraction. And the fraction represents this. It represents the change in the dependent variable divided by the independent. Now I'm going to represent dependent as red. Remember, the dependent variable is always your y. The blue I'm going to represent is the independent, the x. So remember, whatever you plug in is your independent. That goes on the bottom of your fraction. Whatever goes on top is your dependent. So basically, as long as you know that you're going to have your change in y over your change in x, that's slope. That's rate of change. So all we have to do is this. Look at our change in y. Here we increase by 260. Here we increase by 1. What fraction would that be? It would be 260 divided by 1. Go to the next one. We increase here by 260. We increase here by 1. So the change in y, or the change in the dependent variable, is 260. The change in the dependent or independent is 1. The change in the dependent variable is 260. The change in the independent variable is 1. And so that once again is 260 over 1. So the question asks, is the distance with respect to time constant? So yeah, it is constant. And what does the change represent? The change represents this, 260 divided by 1. But you got to understand, the rate of change means two different values. So this means 260 feet for every 1 minute. So it represents the distance that the band marches per minute. And the band marches 260 feet per minute. So turn your book to the next page, and we're going to look at the practice problems number 1 and 2. Now, if we just look at this, all we have to do is realize we have to write it as a ratio. We have to look at everything as a ratio. So right here, my change in my dependent is 6. Here it is 3, and here it is 6. And all of these are 1. So what we have to do is look at this. What was the change here? It was 6 over 1, the change in y divided by the change in x. The change in the dependent divided by the change in the independent variable. So that was 6. Here, the change was 3 over 1. Here, the change was 6 over 1. Is it constant? No. It's not constant because it doesn't increase by 6 over 1 every time. So your answer here is no. So now in example 2, let's look at what our y value is doing, what our dependent variable is doing. We're decreasing by 1,000. Our x value, or our minutes, is increasing by 2. So we could write that as a ratio as 1,000 divided by 2. Here we are we're decreasing by 1,500, and our x value, which is our minutes, is increasing by 3. So that would be 1,500 divided by 3. And lastly, here we're decreasing by 3,500, and here we're increasing by 7. So we can write that as the ratio as 3,500 divided by 7. If we simplified all of these, we would get the same rate of change, which is 500 divided by 1. Now, 500 divided by 1, really, what do we know? We're decreasing. So we have to make sure these are all negative. So all of these are the same. So is this a constant rate of change? The answer is yes. So what is it? Well, it'd be negative 500, or negative 500 divided by 1. Now, what does that mean? It means in this problem, and if you look at your book, it says the title, which is Airplane Descent. That means our airplane is descending at a rate of 500 feet per minute. We are dropping 500 feet every minute, and that would be our answer. The next concept, which is on page 168 in the gray box, this is probably the biggest concept as 8th graders you need to know and you're going to be using the entire year. It is one of those key concepts that you must memorize. All it is slope. So before I read you the gray box, I'm just going to show you what it means. Slope. Slope represents slant of something. Think of the pitch of your house or the roof of your house. That's a slope. A ski slope goes downhill. That's a slope. It is represented by the ratio of the change in y. That would mean you subtract your y values to find the change in y, divided by the change in x, otherwise called rise over run. Rise is how much something goes up or down, falls or increases. Run is left or right. So here's your gray box. The graphs of the ordered pairs, time, distance, like in problem 1, lie on a line shown at the right. The relationship between time and distance is linear. When data are linear, the rate of change is constant. So whenever you have a line, the slope is the same. The rate of change is constant. Notice also that the rate of change is just a ratio of vertical change, which is your rise, to the horizontal change, which is run, between 2 points on a line. The rate of change is called slope. All you do is count how many up, how many down, and then how many right or left, and you turn it into a fraction. So if you look at the distance marched, like the problem we did with the marching band, 260 up for every 1 over. So it's 260 divided by 1. Change in y is 260, change in run is 1. On these next two examples, these are not in your book, but what I want you to do is just look at them. You don't need to write them down. In this example, you will notice that your line is going uphill. Therefore, our slope has to be positive. Here our slope is going, or our line is going downhill. Our slope is negative. We'll get to that a little bit more in a moment. All I want you to do in these two problems is identify how far up and over you go from one point to the next. Always start on the left point. So if you look here, we go up and over. This means up 2, which is positive, right 3. That's positive as well. Your y, remember, your y goes up and down. Your x value goes left and right, so change in y. Change in y is how far up or how far down. If it's up, it's positive. If it's down, it's negative. So we go up 2 over 3. Up 2, that's your change in y. Over 3 to the right is change in x. Therefore, rise over run, your slope is 2/3. If you follow this pattern, up 2 over 3, it would follow the same thing all the way through on that line. It's a constant slope. In the next example, you're going to start at this point and you're going to go down and over to the right. So down, 1, 2, 3, 4. This would be down 4, so we go negative 4. To the right 5. Change in y is negative 4 because we go down 4. Change in x will be to the right 5, so that would be negative 4/5. If you did this mathematically, change in y. Now please don't make this difficult. Change in y. All you do is subtract your y values. So you could do this. Let's subtract the y here, 1 minus negative 1. 1 minus negative 1. And here we have our x values, which are 1 and negative 2. So 1 minus negative 2. That gives us 1 plus 1. And 1 plus 2, which gives us the slope 2/3. Over on the next example, we could subtract our y's, 2 minus negative 2, and our x's, negative 3 minus 2. That gives us 2 plus 2, which is 4, negative 3 minus 2, which is negative 5, which gives us the same slope as negative 4/5. Now look at the got it on page 169. Look at A. It says, what is the slope of each line in parts A and B? Figure out how many up and over or down and over you go. Pause the video if you want. Part A says up would be 2 over 5. So up 2 over 5 would give us a slope of 2/5. B, we go down 2 and over 6. Down 2 over 6 would be negative 2/6, but that simplifies into negative 1/3. And then C asks, in part A of the problem 2, pick 2 new points on the line to find the slope. Do you get the same line? It wouldn't matter what 2 points you pick. It would still work because the line is constant. So no matter what 2 points you pick, you would always get a slope if that's the same thing. Now, one last thing I want you to realize is this. I'm going to draw 4 graphs. These are very poorly drawn, but you don't even need to have a good graph drawn. All you need to know is this. As your line goes uphill, you have a positive slope. As your line goes downhill, and now we always go left to right, left to right, left to right. If you go downhill, you have a negative slope. If your line does not go uphill or downhill, but it remains a constant all the way across, which means it's like a flat surface, it's a slope of 0. And if you have a vertical line, so a horizontal line has a 0 slope. A vertical line has a slope that is undefined. Now, look at page 169 to 170 and read that whole key concept where it says the slope formula. You will notice this. If you have x1 comma y1, all that means is you have an ordered pair on the line. And then you have another ordered pair on the line, x2, y2. What that means is you have another x value and another y value. Those are not exponents. In order to find the slope of the line, you subtract your y values, and that goes on the numerator, and then the denominator is subtracting your x values. And once again, the reason is because this is the change in y. In order to get to the change of two numbers, you subtract them. Over or divided by the change in x, which is your denominator. Here's this you need to make sure you highlight or put a star next to. The last part of your key concept, it says, the x coordinate you use first in the denominator must belong to the same ordered pair as the y coordinate you use in the numerator. Let's do a quick example of what I mean by this. Let's say we have 3, 5 and 1, 2. All we want to do first is you are subtracting your y values on top. You're subtracting your x values on the bottom. So this is how you would do it. 5 minus 2 over 3 minus 1. That gives us 3 over 2, which is our slope. Or you could take 2 minus 5 and 1 minus 3. That gives you negative 3 over negative 2, which also gives you 3 halves. Here's what it means by using the same x coordinate from the ordered pair than you did with the y on top. I cannot do this. 5 minus 2. Notice I started with this ordered pair. You can't then start with this ordered pair on the bottom and take 1 minus 3. They're backwards. So if I started with the 5 on top, I have to start with the 3 on bottom. You have to start with the same ordered pair. So this does not work. So let's go to the got it problem A on page 170. This is really easy. All I'm doing is subtracting my y values first. So let's start with either one. You can start with the 3 or the negative 1. It doesn't matter. I'm going to start with negative 1, and I'm going to subtract 3. Since I started with negative 1, I now have to start with the 4. So then subtract the x values. 4 minus 1. That gives me negative 4 over 3. You know your slope is negative 4/3. That means your line is going to go downhill. All right, so do 5 and 6 on your own if you want. Pause the video, do 5 and 6. Number 5, if you did it correctly, would give you 7/10. Number 6, if you did it correctly, if you subtracted, you get negative 1/3. And you could get the negative on top or bottom, but you still need to call it negative 1/3. Now we're going to go to student page 171. We're going to do A and B. A, 4, negative 3, and 4, 2. Let's start subtracting the y values. 2 minus negative 3 over 4 minus 4. You automatically know you're going to get 0 on the bottom. You cannot divide anything by 0. If you divide by 0, you're always going to get an undefined slope. Always undefined. If you graph this, notice what kind of line you would get. If you graphed 4, negative 3, that would be like right here, and 4, 2 would be right here. You get a vertical line. A vertical line always gives you an undefined slope. B. B is the ordered pair negative 1, negative 3, and 5, negative 3. If you subtract your y values on top, negative 3 minus negative 3, we can stop there. That's a plus. Negative 3 plus 3 is 0. 0 divided by anything is 0. This is a horizontal line. Please, this is huge. Right here. Undefined. Vertical line. 0. Horizontal line. Once again, vertical line, undefined. Vertical line, undefined. Vertical line, undefined. Horizontal line will give you a slope of 0. On page 171 is exactly what I've already taught you. Positive, negative, undefined, and 0. Please look over these key concepts. Slope is an easy concept once you get it, but make sure you understand how it works, how you find it, and how a positive, negative, undefined, and horizontal slope look, or a 0 slope look.